In this video, we're going to look at finding areas of regular polygons. And it's basically assumed at this point we've already discovered the formula, so now we're just going to be applying the formula. So the formula for finding the area of any regular polygon is the area equals 1/2 the apothem times the perimeter. So remember that the apothem is the distance from the center of the polygon down to the midpoint of one of the sides. So let's say we had a square. The apothem would be that distance right there. It's perpendicular to the side that we have. So that's the apothem. That's what we're going to be looking for to help us. We're also going to need the perimeter, and remember the perimeter is all the way around the polygon. What's really cool about this is that it works for any regular polygon, no matter how many sides you have. It can be a dodecagon. It will still work for this. There are other ways to find areas of various polygons, but like I said, today we're just going to be focusing on utilizing this formula for any of the polygons, and you can use whatever method you want depending on the polygon that you have. So in this example, we can see that we have a nonagon. It has 9 sides. We have a couple things given to us. We have the apothem given to us, and we also have one of the sides. So remember that all of these sides have the same length since it's a regular polygon. So if we are going to apply the formula, area equals 1/2 apothem times perimeter, the first thing we have to do is find the perimeter. So we know that it has 9 sides, and each side is 12 units long. So the perimeter is 9 times 12, which is 108. Since we're given the apothem in this problem, the area part is really not too bad at this point. The area is going to be 1/2 times the apothem, which is 16.5, times the perimeter, which is 108. So, utilizing our handy-dandy calculators, we can see that the area of this nonagon is 891 units squared. So here we have another regular polygon. In this case, it is a pentagon because it has 5 sides. Again, let's look at what we have. We know the apothem and we know one side length. And if we're going to apply the formula, area equals 1/2 apothem times perimeter, we basically have everything we need. Again, let's find the perimeter. There are 5 sides on a pentagon, and each side is 7.5 units long. So when we multiply these out, we get a perimeter of 37.5. Since we have the apothem, we're ready to go and apply our formula. The area is 1/2 times 5.1 times 37.5. So when we multiply all of these things together, we end up with an area of 140.625 units squared. Making a big deal of that unit squared because it's important for you to remember the area is that squared measure. It's the space inside that pentagon. Now these pretty not too bad because we have all the information we need. We don't have to do a lot of calculations in between. Sometimes though, you do not know everything you need and you're going to have to apply some reasoning in order to find those. So let's look at one of those. In this example, we have a regular hexagon, and all we know is this distance right here, that 8. Now keep in mind that that is not the apothem. The apothem is going to be right there. And the 8 is the radius of that hexagon. So what we're going to need to do is we are going to need to find the measure of this angle right here, and then we're going to need to apply trig in order to find those other distances that we need. We're going to need to know the side length, and we're going to need to know the apothem. So how are we going to find that angle? Well, keep in mind that when we make all these little triangles inside this hexagon, they're going to add up to be 360, that interior angle measure. So if we know that all of them are going to add to be 360, we can divide that up into the different parts. Now notice that there are 6 triangles, but we really only care about the angle of half that. So I'm going to do 360 divided by 12 to get the angle measure that I need to apply trig to my tiny right triangle. So we're going to do 360 divided by 12, and that's going to get us an angle measure of 30 degrees. So that means that interior angle that I marked blue is 30 degrees. Now if we want to find the apothem, and I'm looking at that triangle, I know the hypotenuse of the triangle, and I'm trying to find the adjacent side. So if I'm using hypotenuse and adjacent, meaning the one that touches the angle, because that's the apothem, I'm going to use cosine. So in this case, I'm going to use cosine of 30, and I know that that equals the adjacent side, my apothem, over my hypotenuse, which is 8. So now we're going to have to do a little bit of algebra to solve this. Multiply both sides by 8. So you end up with 8 cosine of 30 equals the apothem. And when we utilize our calculator in degree mode, since we're dealing with degrees, we end up with an apothem measure of about 6.93. So I'm going to hang on to that number because I'm going to need that for my formula. But remember, the formula is area equals 1/2 apothem times perimeter. And to find the perimeter, you're going to need to find the side length. So that means I am going to be looking for this little unit right down there. I need that so I can find the whole side. So in order to find the side length, or in this case I'm going to find half the side length, I'm going to call it x. If we look at what we're going to be dealing with, if we use the hypotenuse again, we're going to be finding the opposite side. So using the opposite and the hypotenuse, that means we have to use the function sine. So sine of 30 equals my unknown part divided by the hypotenuse, which is 8. Again, we're going to apply a little bit of algebra, so we're going to end up with 8 sine of 30 equals that missing amount, and that missing amount is 4. Now if we go up to our picture, you're going to notice, I'm going to even change colors so we can really see it, that's 4. So the whole side is twice that, which is 8. That's our side length. Now you're looking at that and going, hey, that was the same as the radius. In a hexagon, this actually is kind of a cool feature. Those are all equilateral triangles, and so the radius measure and the side measure are the same, since an equilateral triangle has all same sides. So we could have done that a little bit faster, but I wanted to show you because this method works for any polygon, regardless of whether or not it has equilateral triangles or not. Alright, so it looks like I have the apothem, I have the side length. I need to find the perimeter. So the perimeter is going to be 8, that side length, times 6, because it's a hexagon. So that's going to be 48. Now we can go ahead and apply our formula. The area equals 1/2 the apothem, 6.93, times the perimeter, 48. Go to your calculator, do that calculation, and you are going to get 166.32 units squared. It gets a little bit tricky when you're having to find those different parts, so I'm going to do another example like that. Here we have an equilateral triangle, and we see that we are given the side measure. So if we are going to want to actually find the area using our formula, area equals 1/2 apothem times perimeter, I'm still going to have to find the apothem. Yes, I know the perimeter, but I don't know the apothem. So I'm going to draw that in so I can kind of see what I'm looking for. And I'm going to mark it with what I know. I already know that the whole side is 10, so I know this side is 5. Again, we are going to need to find that interior angle measure so that we can utilize features of right triangles in trigonometry in order to find that missing side. So in this case, since we have this equilateral triangle, we can see that those three triangles are going to add up to 360. But since we only care about half the triangle, we're going to divide it into 6 parts. So to find the angle measure, the theta, we're going to do 360 divided by 6, which is going to get us an angle measure of 60 degrees. So that little guy right there that we're looking for is 60 degrees. So now we are going to apply some trigonometry. I want to find the apothem, and I'm given the side right there. I'm given the opposite side, and I want to find the adjacent side. So in this case, to find A, I'm going to use opposite and adjacent, which means I'm going to use the tangent function. So that means that the tangent of 60 is equaling the opposite, 5, over the adjacent, which is A, in this case, the apothem. So now, let's go ahead and apply some algebra, because algebra is fabulous. And we are going to end up with the apothem times the tangent of 60 equals 5. Now we can divide both sides by the tangent of 60, because that's just a number. So we get the apothem equals 5 divided by the tangent of 60. And that's going to give us an apothem about 2.89. So now that we have the apothem and we can find the perimeter, we can therefore go about finding area. Let's start with perimeter. There are 3 sides, and each side is 10. So the perimeter of this triangle is 30. Applying that to my formula, I can find that the area is 1/2 2.89 times 30. Apply the formula, use your little calculator if you need to. You're going to end up with an area of about 43.35 units squared. So it's always coming back to that exact same formula. Sometimes we're going to have to do a little bit of trig work to find the parts we need. But again, you're always just going to end up eventually doing 1/2 the apothem times the perimeter. And it works for any regular polygon, regardless of the number of sides. I sort of did a little recap there, but I just want to remind us all of what's going on. For finding the area of any regular polygon, you can use the formula 1/2 apothem times perimeter. So remember that the apothem is that distance from the center down to the midpoint of a vertex. And the P is the perimeter all the way around. If you do not have, like if you're missing a side length or the apothem, sometimes you are going to have to apply trig to find those. And that always involves finding the angle measure. So I just want to remind you that that interior angle measure can be found by doing 360 divided by twice the number of sides. Why twice? Well, because remember that each of those triangles is getting divided in half by the apothem to get us that smaller degree. More often than not, you don't have to do that, but sometimes you do, and so it's a good thing to know. So this was finding area of regular polygons.